Good evening, everyone. Hope all is well. Everything and everyone's all right. All right, so today, hold on 1 second, trying to figure out why my it's weird. Okay, so we're looking at 2.6 today, and we have limits involving infinity. All right, basic infinity facts. So we're taking the limit of a constant. K is a constant. As it goes to positive infinity, as your limit approaches positive infinity, or as x approaches positive infinity or negative infinity, it's just going to be that constant. And then the other one, if you have a number over x as x goes to infinity, in other words, 1 over infinity, or even 7 over infinity, any number over infinity, the bottom number is going to continue to get larger and larger and larger. So the number that you continue to evaluate will always go closer and closer and closer to 0. So x goes to infinity. If you have a number over infinity, it will go towards 0. And so in the blue, was just me emphasizing that process. So like I said, x is in your denominator. And if you're talking about x going to infinity, that means x is 1, then x2, x is 3, x is 4, x is 5. X will continue to get larger and larger because it's going to positive infinity. Or even negative infinity, that bottom number will continue to get larger and larger and larger. So 1 over 1 is just 1. And then if you do 1 over 2, that's 0.5. Notice it didn't cut in half. Then 1 over 3 is 0.3. 1 over 4 is 0.25. You see that numbers continue to get smaller. In other words, it's going closer and closer to 0. 1 over 5 is 0.2. Then I just skipped to 10. You see how it's 0.1. 100 is 0.01. And, 1,000 will be 0.001. It continue to get smaller and smaller and smaller. So that's what we're saying right here. A number over infinity, no matter what the number is, even if it's 1 million over x, if x is going to infinity, eventually that x is going to get larger than 1 million because it is nothing larger than infinity. And it's going to continue to approach and get closer and closer to 0. Mm-hmm. All right, can I scroll up? All right, so let's find the limit using those two facts. We have the limit as x goes into infinity of 5 plus 1 over x. So according to what we just said there in those first two basic facts about infinity, 5 is just a constant. X does not affect it. The limit is going to be 5 no matter what X goes to. And then 1 over X is going to 0. So that's what we have right here. That's 5 plus 0, because you can evaluate the limit of each piece individually. And so our answer is just 5. All right. Any problems with A? All right. B, we have the limit of pi square root of 3 over x squared as x goes to negative infinity. So remember I said that if your numerator is any number, it could be 1 million. If your denominator is that variable as it goes to infinity, it's always going to go closer and closer to 0. So if you look at what's up top here, that whole thing up top is a constant. You know, pi times square root of 3 is a number. Right. And so in your denominator is x squared. So that's really infinity squared. So that whole thing is going to 0 as x goes to negative infinity. So that's why the answer is 0. Here I was just emphasizing what I said verbally. Even if it was 1 million over x squared, it's still going to 0. If it's a constant, that constant is going to stay constant. So that denominator is what's going to continue to increase. Any questions? All right. All right, so the next one, we have the limit of 5x squared plus 8x minus 3 over 3x squared plus 2. Look at the limit of that as x goes to infinity. So essentially what we have here, even if we don't evaluate it all the way, you know, we can visually see that we have x squared over x squared. Still have my eraser up. You know, without plugging in values, we have x squared over x squared. And basically, that's going to get so large that we pretty much have infinity over infinity. So that doesn't help us come to a limit or a number of this expression as it goes to infinity. So what we need to do is manipulate the problem in such a way so that we can get an answer. All right. So in the red, it says divide each term by the variable to the highest exponent in your denominator. So that highest exponent in our denominator is x squared. So we're going to divide each term by x squared. Give you guys a chance to write before. Keep pushing up. Oops, sorry about that. So this is what I did here. So this is what we have, 5x squared over x squared plus 8x over x squared minus 3 over x squared over 3x squared over x squared plus 2 over x squared. So we're dividing everything, each term by x squared. All right, so if we simplify, x squares cancel. 1 of the x's cancel here. Here, x squares cancel. Let's still copy that statement. So this is what we have after the cancellation. All right. So now we can evaluate the limit as x goes to infinity. So we have 5 plus 8 over x minus 3 over x squared over 3 plus 2 over x squared. And if we apply the limit as x goes to infinity, we see that 8 over x cancels, well, it goes to 0. 3 over x squared goes to 0, and 2 over x squared goes to 0, leaving us with just 5 in the numerator and 3 in your denominator. So we have 5/3 as our limit. All right, any problems, any questions? All right, so here, the next one, the limit of 11x plus 2 over 2x cubed minus 1 as x goes to negative infinity. So we will divide everything by x cubed. So once again, if you have x in the numerator and in the denominator, we have to divide each term by the highest exponent of x that's in your denominator. So x cubed will be the move to make for this one. So that's 11x over x cubed minus 2 over x cubed over 2x cubed over x cubed minus 1 over x cubed. So one of the x's canceled here. We do x squared. X cubed cancels here. And that's it. So that's 11x squared minus 2x cubed over 2 minus 1 over x cubed. All right, so if we apply the limit, we see that 11 over x squared goes to 0, 2 over x cubed goes to 0, and then 1 over x cubed goes to 0. So we have 0 over 2, which is just 0. So it's okay to have 0 as an answer. That is a legitimate number, but we do not want infinity over infinity. Don't want 0 in our denominator. You know, we have different scenarios that will cause us to have to manipulate the problem in order to be able to solve. So, but it's okay to have 0 in your numerator, just 0 over a number, that's fine. All right, questions, okay. All right. So the limit of sine x over x is going to be equal to 0 as x goes to infinity. Limit of cosine x over x as x goes to 0 is going to be also equal to, I say equal to infinity, equal to 0. And then the limit of cosine x over x as x goes to infinity is equal to 0. So basically, you know, whatever sign is being applied to, that needs to be applied to down here. I mean, that needs to be in the denominator as well. So similar to what we did in the last section. Same thing with cosine, whatever cosine is being applied to needs to be down here. I think that should be a 1 right here. Matter of fact, let me check to make sure I didn't miss something in the text as far as the example is concerned. Sorry, just want to make sure I didn't write something wrong in the notes. See where I got it from. Oh, okay, got you. So I don't necessarily need this 1. Right, because we're going to infinity. Okay, yeah. All right. So we're going to infinity. I don't need that to be 15. I forgot we were going to infinity. So bottom line, if we're going to infinity, that's going to be the same thing. It's going to get so large that it's not going to matter. So yeah. All right. Yep. So it doesn't necessarily have to be the exact same thing as long as there is an x right here. And that's going to infinity. So we'll be fine. The other thing we had in our notes, I believe that was going to 0. And that's why it had to be the exact same thing. Anyway, but yeah. So as long as we have x right here, that will go to 0 as long as x is going to infinity. So it's all about our limit as well, what our limit is going to. All right. All right. So next one, at the infinity, the x going to infinity, we have 5 minus 3x plus sine 6x over 9x plus cosine 6x. All right, so we're going to divide each term by x. Remember, it's all about the largest exponent in your denominator. And this is what we have. All right, so x is canceled here and here. So we can evaluate that limit now. 5 over x goes to 0. 3 as a constant is fine. Sine 6x over x goes to 0. 9 is going to be fine as well. Remember, x is canceled. And then cosine of 6x over x goes to 0. And that leaves us with negative 3 over 9, which is negative 1/3. All right. Any problems? All right. All right. Trying to check something real quick. Make sure you guys are covered. Make sure I'm not leaving any examples off. Because certain things I'm looking at. All right. Wonder why I didn't put that in here. Also, if you're in your math lab assignments, and you see something that you may feel I didn't go over, or the problem's not making sense to you, feel free to ask, because I want to make sure I cover everything. And it looks like I don't know. I feel like I'm missing something in my notes, but anyway, feel free to let me know if you have, if you see something like that, so we can make sure we're covered. So something like this: find the limit of 6 over x minus 4 as x goes to 4 from the right side. I believe we talked about coming from the right side and left side of your values in another section, but that's in this section as well. We know that if we were to plug in 4, get 6 over 0, which is undefined. So that doesn't give us a value. So what we would do is, or what one way we could handle this type of problem, probably the best way to handle this type of problem, I'm trying to think of another way. The best way to handle this problem is to graph. Then all right, so you should graph it and then follow the graph according to the directions of the limit. So we have 6 over x minus 4. So what I would do is just go to a graphing calculator if I didn't have one on me. All right. So 4 is right here. I can't write on this, but you see 4 as far as x. You go to 0 and go to 4. So we're actually going to 4 from the right side. Notice how the graph goes up. If you watch the graph, follow the red line from the right side of 4, it goes up. So that means that our graph is going to positive infinity. All right, it's going up. Now, if we was going to, and notice it said the right side. If it was coming to approaching 4 from the left side, then our answer would be negative infinity because our graph is going down. All right. So if you look at the graph, just me doing a rough sketch. Our graph is going like this. Yep, that ain't good enough. And no, we didn't talk about it in this class, but we talked about it in pre-calc. Where's my blue? Yeah. X equal to 4 is a vertical asymptote. So the graph is not going to cross that line. So if you're talking about, once again, if you're talking about the limit, as x goes to 4 from the right side, that answer is going to be positive infinity. Hold on a second. All right. And then also, just for notes purposes, if I was doing four from the left side, that would be negative infinity. All right. Questions on what we did there. So you have a few of them like that, wherein you remember your if we're not talking about infinity, because of course you can't plug in infinity, but if we're talking about a number like this, first move is to plug it into the function and see if you get a value out. And you notice that we don't here because we get 6 over 0 when we plug that number in. That gives us undefined. So if that's the case, then you have to look at, okay, what's happening as I approach 4 from the right side. And so you have to look at the graph. So you saw that even if you don't have a graphing calculator, there's a whole bunch of free graphing tools out there. Like all I did was Google graphing calculator. First one that popped up was a decent one. And that allows you to follow the graph and to see what is approaching. Once again, if it's approaching positive infinity, your graph is going up. If it's going negative infinity, your graph is going down. All right, let's see if there's anything else here. I think that's pretty much the gist of that section. Okay, I'm using the other one. Any questions, concerns? Everybody good? Trying to look and see if I'm missing anything before we close out today. All right, almost there. It's 2-4. Okay. So yeah, I was looking at a few. Well, one I looked at. Was taking a look at your homework in 2-6. I saw 36 problem. I think all of them don't call for calculation. They got to be why I put that many up there. But and I just wanted you to see all types of scenarios. So that is it for chapter 2. So need you guys to get in there, get into your homeworks, and get rolling. And yeah, take advantage of this weekend. So, we got a 3-day weekend. We don't have class on Labor Day. As far as I know, we're not supposed to have class on Labor Day. So take advantage of that. That means I won't see you for a whole week. Next class, the floor will be open first for any questions. So that gives you a week to come up with whatever questions you have or whatever questions that could be generated. And yeah, and I'll address those first. If I see any problems that look like something I may have missed or whatever, I'll go looking through some things or just stuff I want to reemphasize. I may do those on that day as well. But for the most part, that would be your opportunity to ask whatever you want to ask, your opportunity to bring to the table any problems you've seen, couldn't figure out, or just had a little confusion on. Wednesday will be the day. Outside of that, after 2-6, you have your tests, and that should be posted. That should be available to you. If you don't see it, of course, let me know. After that, if you don't have anything, it's just roll into chapter 3. So it really would be on to your guys' benefit to bring questions to the table. And if you bring enough stuff, then I won't go into chapter 3. But if you have enough questions, have enough things for us to do, then let's say if you don't have anything, then other than us just looking at each other, I will go ahead and go to chapter 3. All right. Any questions, concerns, or comments before we close? Everybody good? Everybody straight? Okay. All right. That's it for today. Have a good one. Be safe. Have a great weekend. And I will see you on Wednesday.